Hi guys, so in the last video we discussed about machine learning. So if you want to quickly revise the last video, you can go watch a 60-second revision video of machine learning. In this video, let's move on further. We are gonna get into artificial intelligence. So what exactly is AI now? AI is a contrast to human intelligence. Okay, it suggests that machines can basically mimic humans if they don't focus on making machines smarter than humans. They focus on making machines mimic humans. Okay, basically the way they talk, the way they think, the way they learn, the way they plan, the way they understand, all these things: talk, think, learn, plan, understand, etc. Artificial intelligence is also called machine intelligence or computer intelligence. Okay, now there are many definitions of artificial intelligence that have evolved over the time. The very first was by Arthur Samuel 1959, in which he suggested that machine learning is a subfield of computer science that gives computers the ability to learn without being programmed. Okay, there's no need to get deep into these definitions. It's basically the concept that you need to understand. Now, there are two types of AI that we are going to discuss. One is narrow AI, the other one is strong AI. Now, what do these two terms mean? Narrow AI includes basically limited to specific areas that we have around today, very common. For example, email spam filters. In our email, we can already choose which emails to put it in the spam folder, right? So they automatically go to the spam folders, whether it's text to speech or speech recognition or self-driving cars or online payments or Google Maps, text autocorrect, chatbots, social media, face detection, robots, drones, Alexa, Netflix recommendations. All these are somewhere based on even ChatGPT. All these are somewhere based on the basically come under the narrow AI. Narrow AI is also known as weak AI. What does this mean now? Weak AI because it is built to simulate human intelligence, whereas strong AI is built to copy human intelligence. Okay, now what is strong AI? Strong AI is the type of AI that copies or mimics human intelligence. It indicates the ability to think, plan, learn, communicate, etc. Strong AI is basically the next level of AI or true intelligence. It moves towards machines with self-awareness, consciousness, and objective thoughts. Again, one need not decide if a machine can think. One need only decide if a machine can act as intelligently as a human. Okay. Now, let's understand. Our main topic in this lecture is going to be machine learning. So, what are the languages in which we can do machine learning? There are many languages: LISP, then R, then Python, C++, Java, JavaScript, SQL. You should know any one of these languages. If you know any one of these languages, you are good to go for learning machine learning. Alright, now let's look at some examples of machine learning. Okay, now sometimes there are some basically softwares or websites that basically you can upload an image of a dog, right, and it will classify it into a dog breed. It will tell the dog breed, right? So all those such websites, they are based on machine learning. How we'll discuss in the later videos, we'll make our own website of a dog breed classifier. But anyways, even for like birds, you can upload a picture of a particular bird and it will give you the bird. Okay, it will give you the classification of that bird, what type of that bird is, or whatever details that are instilled in the website. That depends on your website. right? Then we also have music intelligence. Artificial music intelligence is basically, you might have seen certain videos outside that AI is literally creating the music these days. So it's composing music. So now, can algorithm compose better music than a human? Which is controversial, but anyways, so even that comes under the machine learning example. So there are so many examples of machine learning. We'll ourselves make many projects in this website itself. My aim is to at least make not website, in this lecture series as well, my aim is to make at least 5 projects based on machine learning in this series only. All right, now let's start and dive into the major topics. Now this is where our lecture actually starts. Linear graphs. Okay, this is the first topic that we are going to discuss under machine learning. Now, machine learning often uses linear graphs to show relationship. Now, what is linear graphs? A simple graph like y is equal to ax plus b is a linear graph. Now, important keywords is linear. Linear basically means a graph like this, straight line graph. Then we have slope. Slope is the angle, this angle, okay? Then we have intercept. Intercept means the starting point or starting value. Okay, these are the 3 terms we'll keep in mind. Now, linear means straight. So a linear graph is always a straight graph. Now, let's make a basic linear graph. Here and x-axis, and then a basic linear graph. Okay, this graph signifies that y is equal to x. Okay, now let's move on to slope. If we write y is equal to ax, it is the angle of the graph. Here the slope is the angle of the graph. It is the a value in the linear graph. Okay, then intercept, if we write y is equal to ax plus b, so the intercept, this is the intercept b. Okay, now we should know how to code all this, right? So we are gonna code in JavaScript. I hope all of you are familiar with any one programming language. If you are, you'll be able to understand it even in JavaScript. It won't be a problem. Focus on understanding the logic rather than the code itself. Okay, now to plot a linear graph, first I'm gonna write, basically the first thing I'm gonna do is declare the variable. The variable name is x value. Const is nothing but a keyword used in Java to declare a variable, so don't worry if you don't know. So the first step is to declare a variable. So or an array, let's say. So I'm declaring it as an array. Similarly, for y value, I'm going to declare an array. Now I have both the values. Now I'm going to start generating the values. So how am I going to do this? Basically, the logic is, right now I've created 2 arrays. Okay, let's forget the code and understand. Right now I've created 2 arrays. One is my x value, which will contain all the values of x, and one is my y value, which will contain all the values of y. Now what I want to do, I want to keep adding the numbers. For doing something repeatedly, we use the concept of loops. Okay, so what I'm going to do is, I'm going to use for loop. In that I'm going to define whatever I want to, and then I'm going to use this method of array, which is push method, which basically adds a value to the array. So if I write for, and let's say let x is equal to 0, again let is nothing but a keyword of JavaScript, x is less than equal to 10, and then x plus is equal to 1. Alright, then I write x values dot push x and y values also, because we want the same value. It says x is equal to y graph, right? Push x, because we want the same values. So here I have created a for loop. Basically what this for loop is doing is, when my x is equal to 0, that's I have initiated it. Let x is equal to 0. So right now my x is 0. Then x is less than equal to 10. This is 10. Sorry, this is the condition that we need to check. Is x is 0? Is x less than equal to 10? Yes, x is less than equal to 10 because 0 is less than equal to 10. Then x is equal to x plus 1. And x value push. Like this. We are going to go. Okay. So similarly, we'll get a graph.
Accessibility shortcut.
Okay. Now the next step will be x is equal to 1, x is less than equal to 10, x plus is equal to 1, so 2, and we'll push 1 1 here. Okay. So we'll get a graph which will be 1 2 3 1 2 3 till 10. This is what we have created till now. Not we haven't created a graph till now, but this is what the values we have created till now. So in x array I'll get the values 1 2 till 10. Similarly in y 1 2 till 10. Okay, so now my values are with me. Now the next step will be to define the data. How am I going to define the data? I'm going to create a data array where I'm going to write inside this data array, I'm going to create a dictionary x values. In dictionary we have key and values, right? So that's exactly what this is. And then similarly y values. This is me defining the data. And then mode lines, because this will give me a straight line. Okay, I'm going to close my dictionary, and this is the key, this is the value, key value. This won't be there in the code. So this is just defining the data. First, what I'm doing is I'm creating a dictionary. In that I'm defining that the x values, x axis basically, or x will be the x values, y or y axis will be the y values, and then mode will be line, because I want a straight line, right? Now that this is done, I'll close my data array. Now I'm going to define the layout, how I want it. So const is nothing but a method to declare a variable. Const layout is equal to title, and then y is equal to x. Then I'm going to do, this is something new, plotly dot new plot. This is the syntax for graph. My plot data layout. Okay, so this is the syntax for graph. You need to remember this syntax. It's nothing basically, you are just plotting. You need to remember this keyword, new plot, basically new graph, and then my plot, and then data, the data array, and then layout, where the title y is equal to x, the layout. Okay, so you are basically just displaying all of this. So this is how we'll get our basic graph. Now when this code will be run, we'll get a graph which looks like this, on a straight line, and 1 2 till 10, and similarly 1 2 till 10. Okay, now y is equal to ax. Okay, let's understand the slope. Let's say we'll let a value only, we'll declare, instead of the two values that we declared here, we are also going to declare a third variable, which will be let slope is equal to 1.2. okay, then first we are going to generate the x values as it is, x values dot push x. Now what difference will the slope cause, right? As you can see, y is equal to ax. That means the slope is being multiplied by the values of x for every y, right? So for example, if my x is 1, y will be a. If my x is 2, y will be 2a. So y is being multiplied by slope. Y is basically x into slope. So my slope is 1.2. So what I'm going to do is, instead of straight up pushing x here, I'm going to write x into slope, because this is why. In the previous example my y was x only, right? So I could write x here, but in this example my y is x into slope, so I have to write x into slope. The code we saw previously was for y is equal to x. There was nothing to be multiplied here, but here we have a, so we just need to multiply it by a, and rest all of the will remain same only. All of the code will remain same only. The plotting is same because only the value of x is changing, right? The rest of the graph is same. Also, except like you need to change the title also. This time you can write slope is equal to slope and plus, like this we can change the title. This will print slope is equal to 1.2. That's what we are printing in the title. The remaining code will remain the same. So I hope you know, hope you have understood the remaining code as well. So this will generate a graph for y is equal to ax. Now we'll have another example where we will use the intercept as well. So what will this do and how we'll write the code? Now in this case, basically the equation that we have is y is equal to ax plus b. So pause and think and write in the comments what will be the y values dot push. What will we write in the bracket of that? Here, instead of x, what will we write this time? Pause and think and answer in the comments. It will be x into slope plus intercept. Okay, so this is what we are going to write this time in place of x. Why? Because as the equation this time is y is equal to ax plus b. So ax we already understood. Then we also have plus b this time. B is the intercept. We also need to write whatever intercept you want. Let's say let intercept is equal to 7. So we also need to declare that variable now, and then we are just going to add the intercept to it, and then similarly we can change the title as to slope is equal to slope and intercept is equal to whatever the value of intercept is. But the remaining code, the displaying of the graph remains the same. For displaying of the graph, remember there are 4 steps. First we need to declare the variables or the arrays. The very first step is to declare variables. Whatever variables will use slope, intercept. If none, then arrays we need to declare only. The second step will be to generate the values using loops, right? The third step will be to define the data, and the last step will be a title, basically defining the layout. Second last step. The final step is to plot this graph. In this we use the keyword plot, ly dot new plot, and then in bracket we are going to write all the whatever things we want to plot. For example, we want to plot the data, we want to plot the layout. So this is how we are going to generate a linear graph in JavaScript. Okay, now the next is scatter plots. Basically, okay, one of the most important parts of machine learning, or the most critical parts even of any machine learning project, is to collect the data. This is a critical part of machine learning. Okay, the most common data to collect are numbers, measurements, right? Often data are stored in arrays now, representing the relationship between values like key and value, basically the dictionary concept, key values. Okay, now a scatter plot is basically, it has points scattered over an area. There's no linearity, like it's not linear. It has points scattered over an area, which is representing the relationship between the two values, right? Now it can be any graph. For example, let's say this is my y-axis and then I have my x-axis. Okay, now 2, 4, 6, 8, 10, 12, and here we'll get 100, 200, 300, or let's do 200, 400, 600, 800,000. Okay, now it can be a very varied data. For example, if I say that the value of 2 is at 2 is 150, so it will be somewhere near here. Then I say the value at 4 is 210, so it will be somewhere over here. Then I say the value at 6 is 800. Then I say the value at 8 is 400. So there's no linearity in this graph. It's a very scattered graph. Like it will be something like this. Even another example of a scattered graph can be this, right? These are all very scattered graphs. There's no linearity in them, like this. So these are all examples of scattered graph. Now to create such type of graphs, what we have to do is, okay, in such type of graphs we need to first tell the variable values, const x array. Now in this I need to tell all the values. For example, let's say 50, 60, 70 till 150. Okay, then similarly y 7, 8, 8, 9, 9, 9, 10, 11, 14, 14 and 15. Okay, now I have created two arrays, random arrays. You can create whatever you want. So now I've done the first step, right? Those 5 steps you need to remember for creating graph. Now I've done the first step. What was the second step? Generate values. Even that's done, because in a linear graph we were generating values separately using for loop. In this we have already generated the values because we have given it in the variables itself. So my first 2 steps are done. What was the third step? To define the data. How did we define the data? By creating another array, const data is equal to x array, y array, and then mode lines. This code remains same only for most of the graphs. 90% of your graphs, this code will remain same only. Okay, then we have const layout, because after this was done, what we did was defining the layout, the title in linear graph case. But in this case, what we are going to do is we are going to define the range as well as the title. So how are we going to define the range? For example, let's say this is the graph to basically demonstrate square meters and prices, that based on these square meters 50, 60, 70, the prices are this. So the price is in millions and the value is in square meters. Okay, so in the layout I'll define this, because they don't know that the price is in millions. They don't know that this is the range of the prices, right? Like I need to define the range, that you need to start from, let's say 40. It's starting from 50, you need to start from 40, so that they know that the range is 40 and it's going to 150. So I'll write 160. So the range will be, I need to basically define the range of x-axis, range, and then I'll also have to tell in what unit is this. So instead of, now I need to tell that to the user or the person who is seeing my webpage. So I'll display it in title again, that's square meters. Okay, then we'll get to y-axis. What's the range of y-axis? The first value was 7 and the last value was 15. So let's do 5 to 16. Okay, and the title will be million or price in million or whatever you want to do. Okay, so now I have my x-axis, now I have my y-axis, I have their range, I have their title. So these are the titles of x-axis and y-axis respectively. You might remember in earlier standards we used to create a graph, right? We used to write what this is signifying, what this is signifying, and then one title was for the title of graph, that what graph is this, what are we comparing. In this case we are comparing house prices versus area, right? So now X-axis title is defined, Y-axis title is defined. We'll define the title of my graph, which will be house price versus size or area, whatever. Now I'll close it. After that, the display line, the display syntax, plot ly.new plot, and then my plot, and then data and layout. Okay, so now this is gonna generate a graph with a title, price in millions here, square meters here, then house price versus size at the top, and it will generate a graph with values 40 because we started from 40. Here we started with 6, 8, 10, 12, 14, 16. We went from 6 to 16. Here we went from 6 to 16, right? It's 6 to 16, so sorry, 6 to 16. Okay, here then 40, 60, 80, 100, 120, 140, 160, like this. So it will generate a graph something like this because of our values were something like this, 50 to 150 and whatever. Okay, so now this is how we can generate a scattered plot. So when to use scattered plot? To compare different values, discovering potential trends or patterns in data, or discovering the relation in data. So for such things we can use scattered plots. Now this was the very first topic of machine learning that we have created, because the most important step in machine learning is to collect data. So after collecting data, we also need to organize the data. To organize the data, we can use such graphs. In the next video, we are going to discuss about perceptron in detail. We already discussed a few things about perceptron, but there's a lot more that we'll discuss: the example, algorithm, and everything we are going to discuss. After that, we are also going to discuss about recognition, pattern recognition, the basically classification, how that is done. So that would be it for the next video that we are going to discuss. After that, there are a few more topics that we have to discuss, like training, testing, learning, data, clustering, regression, deep learning. A lot of more topics that we have to discuss, but for now this is it. See you in the next lecture. Thank you.